Hey, friends. Okay, so we're going to begin lesson 5 together today on our differentiation second unit. So this is unit 3 altogether. Today's lesson, as I just said, is really meant to review the tools we have already looked at. I'm just going to hide my face for 1 sec. Questions are going to ask you to calculate the derivative, but they're not going to tell you which procedure to use. It's up to you to recognize the most efficient way. Okay, so along with the basic derivative rules that we've looked at, we have also focused lately on 3 main categories. So we're just going to kind of review those categories together. We've got the product rule, the quotient rule, and the chain rule. So if a function is, if y equals f of x times g of x, so it's like 2 functions being multiplied together, the derivative of that would be the derivative of f of x times g of x plus f of x times the derivative of g of x. Okay, and remember, if I can just get my ink going here quickly, we just often will go fg plus fg, and then just derivatives on the outside there. Okay, if I have the quotient, so I've got a function divided by a function, that ends up again being fg. Now it's minus fg with the derivatives on the outside. And then we just have to remember that we're going to divide that by g squared. That's how to take the derivative for the quotient. Then we talked about the chain rule. Essentially, the chain rule, when you go to take the derivative, you take the derivative of, there actually should be a little bracket there. We take the derivative of f of g of x. Oh, there should be a bracket there too, folks. Okay, there. Sorry. So you take the derivative of f of g of x, and then you multiply it by the derivative of the inside function. Okay, so all of that stuff should feel pretty comfortable to you at this stage of the game. Okay, now, so for each of the following functions, determine the best rule to use first to find the derivative. Choose from the list of below. So we're going to either say, hey, we're going to use basic rules. That's like, when you have 2 that are being added together, you just do the separate derivatives and the separate derivatives together. Those are all the basic rules. Then the product rule, quotient rule, and chain rule that we just talked about. Okay. All right. So first one, e to the x plus sine x. E to the x plus sine x. Okay, well, that's just going to be basic rules, right? It's just 2 small items being added together. I can take the derivative of each item and add them together. Next one, think about what that one might be. Okay, I would look at that as the chain rule. I'm going to have to look at that as e to the something, right? So e to the something, the derivative of that is e to that something, and then I would take the derivative, the derivative of the inside function. Now, take a look at the inside function, though. Where's my ink again? The inside function here then is going to throw in the product rule, okay? Because that's x times the tan of x. So just be careful of that. So we're going to start with the chain rule, then we're going to move to the product rule. Okay. Okay, next one, ln 5x squared plus 1. Again, you're taking the ln of something, so that would be 1 over whatever the something is. But again, then you have to take the derivative of the inside function. So that's going to be the chain rule again. Okay. Y equals e to the x over sine x. That's going to be the quotient rule. Okay, again, all we're trying to do is recognize how would I start this question. Okay, that's the only purpose of our conversation at the moment. 5x ln x, I need you to see that as 5x times ln x. So that would be the product rule. Okay, the cubed root of 4 minus x cubed. Now you may look at that and say, okay, that's the same as, if this helps you a little bit, 4 minus x cubed to the 1/3, right? So I'm going to end up using the chain rule because the 1/3 will come to the front and I'll drop a degree. Then I have to take the derivative of the inside function. Okay. So that would be the chain rule. Okay. Sorry, let me get that one out of the way for you. Okay, so y equals 3 over x to the 4. Now, that's actually just basic rules, okay? Don't get caught into thinking, oh, I see the division statement, I have to use the quotient rule, because the 3 is just a number. So you can think of that actually as y equals 3x to the -4, and then you could just bring the -4 to the front and drop a degree and go that way. So you can just use basic rules for that guy. Okay, that would be fine. This guy, again, it's x times something, so you're going to want to use the product rule. Okay. Okay. Y equals sine x over e to the 2x plus 3. So overall, the first thing I see is I'm going to need to use the quotient rule, okay, because I have a function divided by a function. Then I'm just going to switch colors here for a sec. When I go to do this guy, though, that guy is going to end up using the chain rule. Okay, so I would start with the quotient rule. I would then move into the chain rule. Okay, the arc cos of 2x plus 3. Again, that's the chain rule. I'm going to have to deal with the arc cos of something first, and then I'd have to take the derivative of the inside function. Okay, so that's the chain rule. Awesome, awesome. Okay, if you were asked to differentiate the following 4 functions, which one, oh, let me just hide my head for a sec so you can see the question. Which one does not belong with the other 3? Justify your response. Okay, I laughed because I was reminded of my childhood Sesame Street vignettes where they would give you 4 items and say, one of these doesn't belong. Anyway, I won't sing the song. Okay, so which one doesn't belong? Well, let's take a look at A, B, C, and D. Pause me if you want to talk about it with each other. I'm gonna say B doesn't belong though. Here's why I'm gonna say that. Maybe you've already figured it out, but this is gonna use the product. Oh, sorry. I'm dealing with a new computer here, and I figured out a fast way to cause an eraser to show up, but I don't know how to get the eraser off. That's going to use the product rule. That's going to use the product rule. That's going to use the product rule. Okay, this guy actually will use the chain rule first. So I would say he's the oddball out, like my mama told me I was. So let's see. Answer B. Option B. The rest of the functions would start with the product rule, which is not needed in option B at all. Okay. Which function requires the chain rule in order to differentiate? I'll just hide myself for a sec so you can see that. Which function requires the chain rule in order to differentiate? Okay, very obviously there, that one is A. Okay, because you've got the 5 on the outside, the 5 will come to the front, and that'll be to the 4. And then I would take the derivative of the inside function. So that guy is option A. Okay. All right, try these 4. These make good AP multiple choice questions, by the way. Which function requires implicit differentiation? Did you get it? That's going to be option B. Okay. Option B, because I've got that y cubed there, right? It's when you have multiple y's with multiple exponents that you're going to head to implicit differentiation. All right. Which function does not require implicit differentiation? Well, hopefully you're going to say right away that B does require it. Let's just go with that. Let's start here and say, okay, B for sure requires implicit, and hopefully you'll say D for sure requires implicit. So now we're looking at A or C. The fact that this says sine to the y or sine of y, remember, you're going to have to take the inside function there as well. Like you're going to have to take the derivative of sine y and then multiply it by the derivative of the inside function. And you've got a y here. So you can't get those y's together nicely. So that would also require implicit differentiation. So the answer is going to be C. Okay. All right, if f of x equals x squared plus 2x, determine the derivative of f of ln x. So we're going to plug in ln x for my x value. Okay, remember ln x is also called ln x, or it's the natural log of x. You'll hear all of those discussed. Okay, okay, so I'm looking at f of ln x equals ln x squared plus 2. ln x. Now, I'm going to go take the derivative of this. I've got the chain rule happening here, so I'm going to go get some ink on. Okay, so that's going to come to the front, and that's going to drop a degree. So that will be 2 ln x to the 1. And then I'd have to multiply that by the derivative of the inside function. The derivative of ln x is 1 over x. And then 2 times 1 over x. Okay. That's going to give me 2 over x ln x plus 2 over x. And then that would give me, I'd factor out that 2 over x. So 2 over x ln x plus 1. And then might as well just write it as a cute little fraction altogether. So ln x plus 1 over x. I seem to be writing on a diagonal. Sorry about that. Okay. Right. I'll just hide myself for a second. State the order of how we should apply the rules to determine the derivative of y equals x times, or e to the x sine x, okay? Then determine the derivative. So order-wise, the first thing I need you to see is it's the chain rule. It's e to the x times the derivative of the inside function. Once we go into the derivative of the inside function, it's the product rule, because that's x times sine x, okay? So chain rule first, then the product rule when taking the derivative of the inside function. So here we go. Here is the chain rule, e to the something, the derivative of that is e to the something, times the derivative of the inside function. Well, remember, the derivative of the inside function would be fg plus fg with derivatives on the outside. So the derivative of x is 1 times sine x plus x, derivative of sine x is cos x. Okay, so that leaves me with sine x plus x cos x. And that's as simple as we can make it. Okay. All right, same sort of question, state the order. But now what I need you to see here is the first thing we're going to do is the product rule, right? Overall, what we see here is the product rule. I have e to the x times sine x to the 5. Okay, so product rule. But then when I go to do the sine x to the 5, I need you to see that that's going to be the chain rule because I have a 5 on the outside, like that's sine x all to the 5. So 5 will come to the front, drop a degree, but then I have to take the derivative of the inside function, which would be sine x. Okay. So product rule first, then the chain rule for the derivative of sine to the 5 of x. Okay, so let's do it. Again, I've got the derivative of e to the x is e to the x, so I'll have e to the x sine to the 5 of x plus e to the x 5 sine to the 4 of x times the cosine of x. Okay. I put the times 1 there again just to show you I went inside, the inside function there is x, and the derivative of that is 1. Okay, so e to the x can be factored out. Sine to the 4 can actually be factored out. So that will give me e to the x times sine to the 4x. And what we'll be left with, the first term will be left with just sine x. And then the second term, I've got the 5 still, and I've got the cos x. Okay. Awesome. Okay. Same question, state the order of how we should apply the rules. This time the derivative is y equals sine x over e to the 2x plus 3. So the first thing you would do is the quotient rule. Then when I go to take the derivative of, like, my bottom function there is my g. So when I go to take the derivative of e to the 2x plus 3, the chain rule will kick in. So quotient rule first, then chain rule. A reminder that our quotient rule fg minus fg over g squared. Oh, see, I put that eraser on again. Okay, over g squared. And I got derivatives on the outside. So derivative of sine x would be cos x times e to the 2x plus 3. minus sine x times e to the 2x plus 3 times the derivative of the inside function, which would be 2, over e to the 2x plus 3 squared. Okay, so that's what I'm going to end up trying to clean up. Okay, so e to the 2x plus 3 is common to both of these, so I can factor that out. That would leave me with cos x minus 2 sine x. And then one of my e to the 2x plus 3's will actually divide out. Okay, so I don't need 1 up here and 2 down here. I can just be left with 1 down there. So my final answer will be cos x minus 2 sine x all over e to the 2x plus 3. Okay. Awesome. Okay. If y equals arctan of e to the 2x, determine the derivative of that. Okay. So in our last lesson, we looked at taking the derivative of inverse trig functions. Okay. So we know that the derivative of the arctan, I'm just going to, sorry, I'm struggling to get my ink turning on today, but the derivative of arctan would be 1 over 1 plus x squared, where x is this. Okay. So I'm going to plug that in for that x right there. So it'll be 1 over 1 plus e to 2x squared. Which would look like this, 1 plus, or 1 over 1 plus e to the 2x squared. Then I took the derivative of the inside function. So the inside function is e to the 2x, so the derivative of e to the 2x is e to the 2x times the derivative of that inside function. So I've got 3 layers of the chain rule there. The derivative of 2x is 2. Okay. So now I'm going to clean this up. This just becomes 2 e to the 2x on top, and this would become e to the 4 sum. Okay. Yay. Okay, if f of x equals sine squared of 3 minus x, determine the derivative of f at 0. Okay, derivative of f at 0. So when I go to take the derivative of this is sine of something all squared. So this is the chain rule first. The 2 will come to the front. I'll drop a degree, and then I'll need to take the derivative of the inside function. Okay, so 2 came to the front. So 2 sine of 3 minus x, that's now degree 1. Then I need to take the derivative of the inside function. The derivative of the inside function, I just want to make sure that's clear to you guys. That really started like this. 3 minus x squared, right? So the derivative of the inside function is this. So now I'm taking the derivative of sine of something. Well, the derivative of sine of something is cos of that something. Then I need to take the derivative of that inside function. That's where the -1 is coming from. Okay, so again, it's 3 layers of the chain rule, but hopefully that makes sense for you. Okay, so now I'm just going to clean this up. What I see here, first of all, is I got -1 that I brought to the front, and then I plug in 0 for, so that gives me -2 sine 3 cos 3. Okay, so -2 sine 3 cos 3, that's actually a trig identity. That is sine of 280. So I could now say that that's negative sine of 6. Okay, negative sine of 6. It's fun. All right, good work, guys. We got this. Okay. If ln of 2x plus y equals x plus 1, determine the derivative. Okay, so I'm going to derive this implicitly. So ln of something would be 1 over the something times the derivative of the inside function. So that's going to give me 1 over 2x plus y. And then multiply that by 2 plus derivative of y. And then that'll equal 1 on the other side. Okay. Now, I need to get to the derivative of y by itself. So I'm going to multiply both sides by 2x plus y. and then just subtract 2. Okay, so that's going to give me the derivative of y is 2x plus y minus 2. Okay. All right. That's it for us. Your work is shown. Make sure you go through the practice and make sure you ask me lots of questions as we go through. You guys got this. I'll see you soon. Okay.